The best junior programmer in 2026 might not be human. Imagine opening your laptop, describing an app in one sentence, and watching an AI write clean, working code before you finish your coffee. That sounds exaggerated until you actually see it happen. AI coding tools are no longer just fancy autocomplete. They can build forms, fix bugs, explain logic, write tests, and refactor messy projects in seconds. And that creates a terrifying question for millions of developers. If a machine can already write code faster than most humans, what exactly is left for the human? The surprising answer is not what the panic online makes it sound like. Because AI is changing programming forever, but not in the simple way most people think. Let us start extremely simple. AI that writes code is not a robot engineer sitting inside your laptop. It is a prediction engine. It looks at what you typed, looks at patterns it learned from huge amounts of code, and predicts what probably comes next. The easiest way to understand it is to forget programming for a second. Think about your phone finishing your sentence when you text. Now imagine that idea became thousands of times stronger, trained on software instead of everyday messages, and capable of predicting not just the next word but the next function, the next class, or the next entire feature. That is the basic idea. When you ask an AI to build a login page, connect a database, or create a button that saves user data, it is not thinking like a human architect. It is recognizing patterns that appeared again and again in code written by real developers. That is why these tools can feel magical while still being deeply mechanical. They are amazing pattern machines. And because modern software is full of repeated patterns, that turns out to be incredibly powerful. Most apps reuse the same flows, the same components, and the same logic shapes again and again. That repetition is exactly the terrain where prediction becomes real productivity. So where did that ability come from? Modern coding models were trained on enormous collections of source code, documentation, bug reports, technical discussions, and examples from real projects. During training, the model sees a chunk of code, hides part of it, and tries to guess what belongs there. Then it repeats that process again and again across millions of examples. Over time, it learns patterns of syntax, structure, naming, testing, and problem solving. It learns that certain database calls usually come with error handling. It learns that login systems need validation. It learns that developers often write a test after adding a feature. It even absorbs common mistakes and the fixes that usually come after them. That is why AI can often sound like an experienced developer. It has consumed a giant compressed library of how programmers talk, think, and build. But here is the key detail. It still does not truly understand your business, your hidden constraints, or what your users actually need. It knows patterns at massive scale. That is its superpower. And that is also its blind spot. When the pattern matches reality, the result can be stunning. When reality breaks the pattern, human oversight becomes everything. This is the part that shocks people. AI is already better than many programmers at specific categories of work. Not all work, specific work. Give it repetitive boilerplate and it flies. Ask it to build a form, wire an API call, convert code from one language to another, explain a confusing function, or generate a first draft of unit tests, and it can save hours instantly. It is also strangely good at debugging obvious issues because it can compare your broken code against countless clean patterns it has seen before. A tired human stares at the same bug for an hour. The AI spots a missing parameter, a bad import, or an inverted condition in seconds. It never gets bored writing documentation. It never complains about renaming variables. It never loses patience doing the same setup task 10 times. That matters more than people realize because a huge percentage of real programming is not cinematic genius. It is cleanup, repetition, translation, and maintenance. In exactly those lanes, AI can look almost unfairly efficient. That is why teams using it well are not just saving minutes. In many cases, they are compressing entire days of routine effort. But if you only watch impressive demos, you miss the trap. AI does not struggle most when code is complicated. It struggles when reality is complicated. Vague requirements destroy it. Hidden business rules destroy it. Legacy systems with years of undocumented decisions destroy it. Security assumptions, compliance rules, edge cases, weird customer behavior, and product trade-offs are where human judgment still matters. An AI can produce code that looks polished while quietly solving the wrong problem. It can write an elegant function that breaks under real traffic. It can create tests that only prove its own wrong assumptions. And because the output sounds confident, inexperienced users can trust it far too early. That is the dangerous part. AI does not announce uncertainty the way a careful human engineer might. It often gives you something that appears finished. So the human role is no longer just writing every line. The human role is deciding what should exist, what cannot break, and what counts as correct in the first place. In other words, the highest value work moves upward from typing code to defining reality. So why does AI sometimes feel better than a lot of real programmers? First, speed. It can produce in 10 seconds what might take a junior developer an hour. Second, memory. It can pull patterns from many languages, frameworks, and styles without needing coffee, sleep, or a long search through documentation. Third, consistency. It does not get emotionally attached to ugly code. It will rewrite, summarize, and reorganize all day without ego. Fourth, breadth. A single model can help with front-end code, back-end logic, SQL queries, test cases, and documentation in one conversation. Most humans specialize. The AI can jump layers instantly. But there is a deeper reason too. Many programmers are average because most humans are average at most jobs. AI does not need to beat the top 1% to feel revolutionary. It only needs to outperform the messy middle of routine coding work. And in many environments, it already does. That is why the panic feels so real. People are not comparing AI to the best engineer in the world. They are comparing it to the average day at the office. And average work is exactly where automation has always hit first. This does not mean every programmer disappears. It means the shape of programming changes fast. The first pressure lands on entry-level work because that is where repetition is highest. Small bug fixes, CRUD screens, simple migrations, documentation updates, and first draft tests used to be training wheels for juniors. Now AI can do much of that in seconds. That creates a new problem. If beginners do less beginner work, how do they become seniors? At the same time, strong developers become dramatically more powerful. One good engineer with AI can prototype like a small team. Product managers can validate ideas without waiting weeks. Founders can ship tools they never could have built alone. New roles also appear around verification, system design, AI workflow design, code review, integration, security, and decision-making. So the future is not no coders. It is fewer people being paid only to type routine syntax, and more people being paid to direct systems, verify outputs, and connect code to real business value. The keyboard still matters. It just stops being the whole job description. If you are a beginner, this technology is not a reason to quit. It is a reason to learn faster. Use AI to explain code line by line. Ask it to compare two approaches. Ask it to generate a rough draft, then force yourself to inspect every decision. Build tiny projects sooner than you thought possible. If you are already a developer, stop treating AI like a toy and start treating it like a high-speed junior teammate with terrible judgment. Give it clear tasks. Ask for plans before code. Ask for tests. Ask it what assumptions it made. Ask what could break in production. Then verify. The people who win will not be the people who mindlessly paste AI output into production. They will be the people who turn AI into leverage. That means taste, judgment, product thinking, and verification become more valuable, not less. The real opportunity is not just writing code faster. It is becoming the person who can turn ideas into working software at a speed that used to require an entire team. That shift is enormous for students, freelancers, startups, and anyone who has been blocked by technical complexity. AI writing code is not the end of programming. It is the end of programming as pure typing. The people who fall behind will wait for the old workflow to come back. The people who move ahead will learn how to direct, test, and sharpen these tools until they become a real advantage. That is why this moment matters so much. The question is no longer whether AI can code. The question is whether you can adapt before the gap becomes impossible to ignore. If you want more videos like this, subscribe and follow Oops, It's AI. See you in the next one.